In the infancy of the universe, just a few 100 million years after the Big Bang, everything was supposed to be chaotic, turbulent, and undeveloped. This was the era when stars were only beginning to form. Galaxies were supposed to be small and messy, and light itself had just broken free from the fog of creation. But according to new data from the James Webb Space Telescope, JWST, that assumption may be completely wrong. JWST's ultra-sensitive infrared vision allowed scientists to peer deeper into time than ever before. When astronomers analyzed faint light from objects billions of light-years away, they expected to see tiny, primitive galaxies still forming their first stars. Instead, they found something completely unexpected: fully formed, massive galaxies, some as large as our Milky Way, already in place just 500 to 700 million years after the Big Bang. How is that possible? Not only were these galaxies huge, but they were filled with mature red stars. Stars that should take billions of years to evolve. Yet here they were, glowing softly in the earliest chapters of cosmic history. If these galaxies are real, and the evidence keeps stacking up, then something about our understanding of cosmic evolution is broken. It's like finding a fully grown tree in the middle of a field that was supposedly planted yesterday. These galaxies shouldn't just be improbable, they should be impossible. But that's not all. The composition of these early galaxies also challenges what we thought we knew. Some of the stars appear metal-rich, meaning they contain elements heavier than hydrogen and helium. Elements that are only formed in older generations of stars through nuclear fusion and supernova explosions. How could such complex materials already exist in galaxies so soon after the Big Bang? One theory is that the early universe formed stars and galaxies much faster than we realized. Perhaps starburst activity, rapid periods of intense star formation, was far more common in the early cosmos than previously believed. Another theory? Dark matter and dark energy played a more aggressive role in shaping the universe than we thought, pulling structures together at a faster pace, accelerating gravitational collapses and mergers. And yes, some even speculate about new physics, forces or particles we don't yet understand, reshaping our models of how the universe came into being. But the mystery goes even deeper. Some scientists question whether these objects are even galaxies at all. Could they be dense clusters of stars or black hole-powered quasars, mimicking the appearance of a galaxy? Could the JWST's instruments be picking up optical illusions, distorted by the lensing of gravity over vast distances? Right now, astronomers are working tirelessly to verify the findings. But if confirmed, this discovery would rewrite textbooks, reprogram simulations, and force us to rethink the timeline of the universe. It would mean the universe matured much faster than we believed. It would also suggest that our place in cosmic history is even more peculiar than we imagined. And this isn't the first time JWST has disrupted the status quo. From spotting carbon-based molecules on exoplanets to revealing galaxies hidden behind clouds of dust, James Webb is proving one thing over and over again: the universe is not what we expected. It's more complex, more dynamic, and, in many ways, more mysterious than any theory dared to predict. So where do we go from here? New studies will reanalyze this early data, apply more precise models, and attempt to peer even further back, perhaps to just 200 million years after the Big Bang, into the era of the first stars. Upcoming observations could determine whether these forbidden galaxies are truly anomalies, or if the early universe was far more crowded, bright, and structured than we ever imagined. Whatever the outcome, one thing is certain: we are witnessing a revolution in astronomy, and it's only just begun.